Let's look at problem number 3, found on page 720 of your textbook. Again, this is in lesson 11.4 on volumes of prisms and cylinders. We're going to specifically look at the volume of a cylinder this time. And the volume of a cylinder, again, the generic form of all of these is that volume is equal to the area of the base times the height. Because the area of the base of a cylinder is a circle, then the b here is going to turn into pi r squared because that is the area of a circle times the height. So that's why this formula here is pi r squared times height. So now once we have our formula, it's simply a matter of just plugging in. It's going to be pi times the radius, which you can tell from right here, excuse me, I kind of marked it out, is 3 centimeters. So you can see that they plugged in a 3 right there and squared it. And then the height here goes in for your h here, and that is 8. So they plugged in an 8 right there. Now, it said leave in terms of pi. That means don't put pi in your calculator. Just calculate the other numbers and then put pi as part of your answer. So 3 squared, of course, is 9, and 9 times 8 is 72. So we're going to leave that as 72 pi. And then again, you've got centimeters, centimeters, and centimeters, or centimeters cubed as part of your answer. So your overall answer is going to be 72 cubic centimeters. Okay. What is the volume of the cylinder at the right in terms of pi? Now, if you'll remember early on in this particular chapter, they were talking about, right before example 1, an ideal called Cavalieri's principle. And what Cavalieri said is whether the cylinder is standing upright or whether it's leaning, as long as you take the true height of that object, it's going to have the same volume whether it's standing upright or whether it's leaning, providing you take the true height of it. So as we look at this particular problem, again, the volume is equal to the base times height, and in this case, again, because it's a cylinder, it's going to be a circle. So it's pi r squared times height. So it's going to be pi, and the radius here, if the whole way across there it looks like it's 2, then the radius is simply just 1 squared, and then the height is this over here, which is 3. Sometimes you have to find that, but this time they gave it to us. And so it just simply ends up 1 squared is still 1 times 3 is 3 pi, and of course that's going to be meters cubed. So that's going to be our volume. And it says here, suppose that the radius of the cylinder is halved. How is that going to affect the volume of the cylinder? Well, remember, whatever you put in as your radius here, whatever the radius is, if you half that, remember whatever you do gets squared. So, for instance, if I took half of something and I squared it, half squared is really 1/4 of something. So when you half the diameter, you're going to end up taking 1/4 of the volume of it, only because in the formula the radius is getting squared. So if you took 1 to 1/2, you would be taking 1/4 of it. So that's what would happen in the explanation here. When you take half of the radius, or you would be really taking 1/4 of the overall volume, only because in the formula the radius gets squared as part of the overall formula in doing that. Okay? Best of luck.